For this video, we will learn the definite integral, its properties, and how to use or how to solve or evaluate definite integral of a function. So let's have the general formula for the definite integral. That is the integral from a to b of f of x dx is equal to f of x, or the integral from a to b, and this is equal to, let's use another color for this one, this should be equal to f of b minus f of a. Take note that for the definite integral, we don't have our constant of integration. So if in the indefinite integral we make use of the constant of integration, we always add it at the end of our integral. For the definite integral, we automatically eliminate the constant of integration. Your a here, the one that is below, use another color. The one that is below, a here, is what you call your lower limit, and b here is what we call our upper limit. So after taking the integral, we will substitute these values, the lower and the upper limit, and you substitute first the upper limit and then subtract the function substituting the lower limit of the integral, the definite integral. So there are some general properties that we need to consider before we start with some examples of the definite integral. So let's have the general properties. General properties of the definite integral. So the first one among the three would be the integral from a to b of f of x dx is equal to the negative integral from b to a of the same function fx dx. That is the first of the general properties. Second one would be the integral from a to b of the function of x dx is equal to the integral from a to c. Let's introduce another limit. Take note that this c is between a and b. So that would be f of x dx plus the integral from c to b of f of x dx. Take note that this c is between the values a and b. So the next one would be the third and final among the general properties of our definite integral would be the integral from a to b of the function of x dx is equal to the integral of from a to b of f of z d sub z. Okay, so those are the three general properties of our definite integral. Before we proceed again, let us first learn about the integrals of odd and even function. So for the integrals of odd and even functions, let us first differentiate between the two, the odd and even function. First one, if f of x is equal to f of negative x, then this is an example of the property, rather, of an even function. For example, let's say you have a function of x, and that would be equal to x squared minus 3. If you will look for f of negative x, meaning we will substitute negative x to x, because that's what functions are. We will input a value to the function and then you will arrive with an output. These two values should be the same for it to be considered an even function. So let's try to check whether they will be the same. F of negative x is equal to negative x, the quantity squared, minus 3. And negative x raised to 2 will be equal to x squared, because negative times negative is a positive value, and that should be x squared in value, minus 3. So if you will notice, f of x is equal to f of negative x, meaning this function, x squared minus 3, is an example of an even function. And for even functions, we have this property that the integral from negative a to positive a of the function of x dx is equal to 2 times the integral from 0 to a of the same function dx. So that is for even functions. For odd functions, we will have if f of x is equal to negative f of x, when you negate the value of x, then it is an odd function. So for example, let's say we have this function of x raised to 3 minus 3x. Let's try to negate this value. Let's try to look for f of negative x. This is equal to negative x raised to 3 minus 3 times negative x. Negative x raised to 3 is equal to negative x raised to 3. Negative 3 times negative x would be positive x. If you will notice, they don't have the same sign, meaning this is not an even function. If you will factor out the negative value, or the negative sign rather, this would be x raised to 3, factor out the negative sign here, this would be negative, or this should be 3x, negative 3x. So f of negative x is equal to negative f of x, meaning this is an odd function. So for odd functions, we will have a property that the integral from negative a to positive a of f of x, or a function of x dx, is equal to 0. So that is the property of odd functions definite integral. So let's have examples on how to find the definite integral of functions. Let's have a few examples. If, for example, number 1, you're asked to find the integral from 0 to 1 of y squared minus y raised to 3 dy. The first step here would be to find the integral. And applying the power formula, this would be equal to y, copy the base. Your exponent would be the exponent plus 1 divided by the exponent plus 1. Don't forget the other part, minus y raised to 3 plus 1 divided by 3 plus 1, using the general power formula of same thing with the indefinite integral. It's just that we are eliminating the constant of integration. And don't forget to write the limits, that is from 0 to 1. If you will simplify, this is y raised to 3 over 3 minus y raised to 4 over 4. And that is from 0 to 1. Next step would be to substitute the limits. So you substitute first the upper limit, because in our formula, let me just rewrite the formula. Formula states that the integral from a to b of f of x dx is equal to the integral from a to b, and that should be f of b first minus f of a. Take note that is always subtraction. So let's apply that in our problem. This would be upper limit is 1, so this is 1 raised to 3 over 3 minus 1 raised to 4 over 4. That is f of b, f of function of the upper limit, minus 0 raised to 3 divided by 3 minus 0 raised to 4 divided by 4. So this is our answer. Simplifying, we have 1/3 minus 1/4. Don't forget the parentheses or the bracket. Minus 0 raised to 3 is 0 divided by 3. That should only be 0. Minus 0 raised to 4 is 0 divided by 4 is 0. So 0 minus 0 is 0. Any value that will be taken from here, so you subtract 0, will just be the same value. So this is equal to 0. So 1/3 minus 1/4 would be equal to 1 over 12. Let's demonstrate it using the basic fractions. Get the LCD, that is 12. 12 divided by 3 is 4, times 1 would be 4. 12 divided by 4 is 3, times negative 1 is negative 3. So this is equal to 1 over 12. This is the answer for our definite integral. Last example should be easy. I just taught you how to use the limits. So this is integral from negative 1 to positive 2 of x squared times 3 minus 2x dx. This should be equal to the integral of from negative 1 to positive 2. Distribute this value, x squared. This is 3x squared minus 2x raised to 3 times dx. Then taking the integral, this would be 3x raised to 3 over 3 minus 2x raised to 4 over 4. From negative 1 to positive 2. If you will simplify, 3 divided by 3 is just 1, so it will cancel. 2 divided by 4, this will cancel to 1, and this would be 2. So we have x raised to 3 minus 1/2 of x raised to 4. And don't forget your limits from negative 1 to positive 2. Substituting, don't forget to substitute the upper limit first. This is 2 raised to 3 minus 1/2 of 2 raised to 4. And minus negative 1 raised to 3 minus 1 half of negative 1 raised to 4. So we have your answer. Simplifying, that would be 2 raised to 3 is 8 minus 1 half of 2 raised to 4. That should be equal to 0 because the other 2 here will cancel, and 2 raised to 3 minus 2 raised to 3 is 0. So this is just 0. You are left with negative of negative 1 the quantity squared, or raised to 3 rather, minus 1 half of negative 1 the quantity is raised to 4. So this should be equal to 3 halves. Positive 3 halves. This is our answer for the definite integral. So that is how you use the properties and how you evaluate the definite integral of certain functions. Later on, after this video, I will upload another discussion regarding the applications of the integral in finding areas of plane curves and centroids of plane curves. Thank you so much for watching.